Good day, viewers at home. This is a lesson on differentiation, how to find the derivative of a given algebraic term or expression. So if you have a function y equals ax raised to power n, and you have to differentiate the function with respect to x, which you know as the y dx. We are differentiating the function y with respect to x. It will simply be, we multiply the coefficient by the index, that is an, then we will now subtract 1 from the index. So it's as simple as that. You multiply a by n, which is an, then you have your x, then you now take away 1 from the index, which is n, so n minus 1. Let's take, for instance, you have y equals 3x squared. So if you have y equals 3x squared, the derivative of y will be dy dx is equal to, from what we've done here, an, that is 3 multiplied by 2. 3 multiplied by 2, then you bring down your x raised to power, the index is 2 minus 1. So 3 times 2, 6x. 2 minus 1 is 1. And of course, this one is not necessary. We don't need to write, n raised to power 1 is still the same thing. So you just simply write x. So this is how to differentiate an algebraic term. When you have an algebraic expression which is longer than this, say you have y equals 5x cubed minus 3x squared plus 4x. The y, the x. Now, if you differentiate y with respect to x in this expression, it will be 5 times 3, 15x. Then you take away 1 from that 3, you are left with 2. So we've differentiated this part now. Minus 3 times 2, 6x. If you subtract 1 from these two, you are left with 1. Plus, this is 4x. This 4x is something as 4x raised to power 1. So if it is raised to power 1, that means 1 multiplied by 4 is 4. So by the time you now take away 1 from this 1, it will remain 0. And of course, anything raised to power 0 is 1. So then we are left with only 4 there. So this one is invariably telling us that whenever we have something like this, y equals kx, that is, coefficient of x here is k, and x is not carrying any power, or meaning the power of x here is 1. If you differentiate the function with respect to x, it will just give you that coefficient. So that means if you differentiate 5x, you get 5. If you differentiate 3x, you get 3. 2x, you get 2. X will give you what? 1. Because x means 1x. So when you differentiate 1x, you get 1. So this is how to differentiate any algebraic term. Sometimes we have it to be a little bit complicated, which we know as a chain rule. If we have something like this, y equals 3x squared plus 5 raised to power 4, and we are asked to differentiate, find the derivative of y with respect to x. In this case now, we have 3x squared plus 5 in brackets raised to power 4. So does it mean that we are going to expand this bracket in 4 places before we now start differentiating? No. This is what we know as chain rule. So for us to get the y dx, we will start this way. First of all, we will say let u be 3x squared plus 5. we represent what we have inside the bracket here with u. So if u represent 3x squared plus 5, it means my y will now be u raised to the power of 4. We can see that y initially was 3x squared plus 5 raised to the power of 4. And now we have replaced this 3x squared plus 5 with u. So that means y is now u raised to the power of 4. So our dy dx will now be dy du multiplied by du dx. So this one simply means we will differentiate y with respect to u. We will differentiate u with respect to x. So here, du dx, if we differentiate u with respect to x, don't forget, as we did earlier, 3 times 2 is 6. Then if you take away 1 from these two, it will remain 1. So it will now be 6x plus this 5 is a constant. It's not carrying any variable x. And when you differentiate a constant, it gives you 0. So that means there is nothing for us when we differentiate 5. So to differentiate 3x squared plus 5, now we get 6x. If you differentiate this with respect to u, dy du now, you know what we have here is 1. So 1 times 4 is 4 u. Then subtract 1 from this 4, you have 3. So this is 4u raised to the power 3. So if you now substitute dy du, which is 4u raised to the power 3, multiplied by du dx, du dx is 6x. So we are supposed to get our answers all in form of x. That means we will now take this u back to the original form. You know, our u is 3x squared plus 5. So that means our dy dx will now be 4u cubed will now be 4 bracket cube, then multiply by 6x. So if you multiply 4 by 6x, you have 24x in bracket 3x squared plus 5 cube. You can see we multiply 4 by 6x and get 24x. We cannot use this 4 to open this bracket. Why? This expression in the bracket is carrying a power here. And until you expand this power, there is no way you can multiply it by this 4. But 4 can be multiplied by 6x to give us 24x. So this is our final answer. But in a situation whereby your question is multiple choice, like objective, this chain rule can be done in another easier way. When you have a question like this and you're asked to get your dy dx, all you need to do, that is in a situation whereby the examiner is only interested in your answer, not workings. First of all, you bring down this power 4 multiplied by, then you differentiate what is in the bracket. If you differentiate 3x squared like we did earlier, you get 6x. If you differentiate this, it will amount to nothing because it's a constant. Then you will now copy the same question back. Now you take away 1 from this 4, it will remain 3. So you can see that the steps are just 3. First, bring down this 4. Secondly, differentiate what you have in the bracket, 6x. Then multiply by, write the same expression and subtract 1 from the power. So you now end up with 4 times 6x, 24x, times 3x squared plus 5 raised to power 3. So you can see that what we have here, you see the same answer that we got earlier. Just that this method is faster than this. But in a situation whereby you have to show your workings, you use the first method, not this. This one is just a way of saving our time. So in our next lesson, we'll take more questions on this chain rule, before we go to product rule and quotient rule. Thank you.